Hello, Matthews Gatos here. We're going to do page 325, number 5. So in this one here, we have triangle ABC. So we'll just draw here A, B, and C. Just pick any points on the triangle. I just want to really spread it out. So it's inscribed on the triangle where AB equals AC. So it's an isosceles triangle. Remember, isosceles triangles have two equal sides, but the base angles are also equal. Okay, it's inscribed in a triangle with a circle, center point O, radius of 10. Find the angle of BAC that produces a maximum area. So we're trying to find this one here. So let's draw in the center of the circle and kind of connect those dots there. So this is the center of the circle. I'll call it O. This is also an isosceles triangle, and the radius here is 10 and 10, which means that my base angles are equal. Now, because I want to find the the area of the big triangle, I'm going to draw in the height of the big triangle. So from the vertex to the base passing through the center, I will draw the altitude, which is the height, which splits these two sides into equal pieces. So these two here are also equal. So I'm going to work in my bottom triangle because my two little triangles at the bottom, because I have a radius of 10, and I'm going to call this one here the height. Now I'm going to work in the little triangles. So I'm going to find base 1 of the little triangle, height of the little triangle. But in terms of the big triangle, ABC, I know that the height of the big triangle, the big height, is going to be the little height of the triangle plus 10. Now, why plus 10? Because from the center to the point here, this is also 10. So my whole height is going to be the little height plus the 10. That's my big height. Maybe I'll use a big H. Okay, and then my big base, the base of the entire triangle B to C, is going to be the little base 1 plus another little base 1. So we'll kind of keep that in mind as we go along. So back to the little triangle, let's look at angle X. So angle X, let's try sine. So sine of X is opposite height over hypotenuse 10. Multiply both sides by 10, and 10 sine X is equal to the height. So back over here, my big height of my triangle is going to be my little height, 10 sine X plus 10. Okay, let's do cosine. So cosine of angle X is adjacent, which is base 1, over hypotenuse 10. Multiply both sides by 10, and 10 cos X is base 1. So in my big triangle, it's base 1 plus base 1, so 10 cos X plus 10 cos X is 20 cos X. Okay, so I want to find maximum area, so now that I have the base and the height, let's do our area. So area is equal to base times height divided by 2. So distributing this in, I have 200 cos X sine X plus 20 times 10, 200 cos X, all divided by 2. Okay, so that is going to be, divide everything by 2, 100. I'm going to write it as sine X cos X. Doesn't really matter, but I'm going to write it like that because then I see a double angle identity here. So 100 sine X cos X. I know that 2 sine X cos X is the double angle identity sine 2X. So I'm going to rewrite that as 50 times 2 sine X cos X plus my 100 cos X. So area is equal to 50 sine of 2x plus 100 cos x. So the simpler you make your original function, the simpler you make your first derivative. Okay, so let's copy that over to another page and let's do the first derivative. So 50 sine 2x plus 100 cos x. Let's take the first derivative. So 50 times derivative of sine is cosine 2x. It's not just x, so I have to do chain rule. Derivative of 2x is 2. Plus 100 times cos x. Derivative of cos x, it's a c function, so it's negative sine x, and the derivative of x is just 1. Okay, so I'm going to have 100 cos of 2x minus 100 sine x. Okay, now I want to set that equal to 0 and solve. So I'm noticing that I have a double angle, cos double angle identity. So let's first of all maybe start by factoring out 100. So I'll have cos of 2x minus sine x. And then remember, cos of x has two different formulas to use. Since I already have a sine x in the brackets here, I'm going to choose the cos 2x formula that involves just sine. So instead of cos of 2x, I'm going to write it as 1 minus 2 sine squared x minus sine x. Ooh, and I don't want my leading coefficient to negative, so I'm actually going to take out a -1 and rewrite this as 2 sine squared x plus sine x plus 1. Ooh, this is a very interesting question. Okay, so now I'm going to factor -100 times. They're really making us work for this critical value. Okay, so I'm going to factor this as 2 sine x and sine x, 1 and 1, and this is going to be positive and negative. Oh, I just noticed I made a mistake here. This, when I factor out that negative, should be a -1. Okay, let me just make sure I'm all good. Yes, I am. Okay, so 2 sine squared, sine minus, okay, we're good. So critical value, set each factor to 0. So I'll set -100 times 2 sine x minus 1 equals 0, and I'll set sine x plus 1 equal to 0. Okay, so my first one, divide both sides by -100. And then I'm going to add 1 divided by 2. So sine x is going to equal to 1/2. Okay, here I'm going to subtract 1 from both sides. Okay, well, sine is equal to 1. Where does that, or 1/2, where does that happen? Well, it's equal to 1/2 when it's 30 degrees. So I'm going to say that my critical value is pi over 6. Okay, here, -1. Sine is -1 at 270. And that's too big to be in the triangle. So this is not a possible critical value for this question. So it looks like my critical value is pi over 6. We just need to verify that that is actually going to give us a maximum. So I'm going to go to my second derivative test. So let's go back up to our first derivative. I'm just going to look before I started factoring it and stuff. I'm going to take this one here, and then I'm going to look at my second derivative. Okay, so my second derivative is going to be 100 times derivative of cosine is negative sine 2x, and then times that by 2, and then minus 100 times derivative of sine x is cos x. Okay, let me just make this a little bit bigger so I can write better. Okay, so second derivative is going to be, that's -200 sine of 2x minus 100 cos of x. So this is going to be -200 times sine of 2 times pi over 6 is pi over 3 minus 100 times cosine of pi over 6. So we just want to know, is this positive or is this negative? So -200 times sine of pi over 3 is root 3 over 2 minus 100 times cos of pi over 6 is root 3 over 2. Okay, so I have, let's see here, I have -200 root 3 over 2 minus 100 root 3 over 2. I don't really care what the answer is, I just can clearly see that's negative. So since the second derivative is less than 0, that means it is concave down, which means it has a max. Yes. Okay, wow, a lot of work here. So pi over 6 is my critical value that's going to work for a maximum area. But let's go back over here because they didn't ask us for x. Okay, so we have found that x is equal to pi over 6. Now we're really looking at theta in the very big triangle. So we've got to do a little bit of work here. So I am going to just erase my drawing here. I want to just redraw this here, just focusing on the angles, okay? So I had this triangle here, Oh, I didn't do a very good job drawing that. Let's just pretend. And then I had this one here. So I'm going to work just with degrees right now to help us visualize this a little bit better, and then we'll put it back into radians. So pi over 6 is 30 degrees. So I know that this is 30 degrees and this is 30 degrees. Sorry, a little bit messy there. Let me make this actually bigger so I can write on it. There we go, so much better. Okay, let's try that again so I can write it nicely. Oh my gosh, this triangle is awful. Please forgive me while I just erase this because it's really messy. Okay, so let's try this again. Okay, so drawing my big triangle. There we go. And then drawing in the central angle with the radius. Okay, that's a bit better. Not perfect, but it's better. Okay, so we found this angle here. Pi over 6 is 30 degrees. This is 30 degrees. This is the angle that I want. So we have to do a little bit of work here. So I know if this is 30 and this is 30, that's 60. So this angle here has to be 120 because angles in a triangle add up to 180. Now, there's a rule. You haven't seen this rule since grade 9. Here's the rule. Angle BAC, which is the one that we want, that is a inscribed angle. But it cuts the circle. See how it cuts the circle B and C with this arc here along B and C? It cuts the circle there, and it is equal to 1/2 of the central angle, which is BOC. So this is a rule that we learned quite a few years ago. Inscribed angles are half the measure of central angles if they cut them in the same place. So that really means half of 120 is 60 degrees. So the angle that is going to give a maximum area is an angle that's 60 degrees or pi over 3. Lots going on in that question. I'm really glad you guys asked me that one. So I hope that that makes sense. I'll just put it bigger so you can see it again. We went through, we found the area in terms of the base angle, x. Simplified it, found the first derivative, critical value, proved that the critical value gave a maximum value, and then took that base angle of x back in my triangle to figure out what the top angle, which is the angle that I wanted. So I hope that that video helped.